Hey guys, today's video is about clock divided by 3 circuit or frequency divided by 3. So what does clock divided by 3 or frequency divided by 3 means? As you can see over here, there's a master clock and generated clock. We have generated this clock using this master clock. So as you can see, 1, 2, 3, 3 master clock period is equals to 1 generated clock. So what happens here is frequency of master clock is divided by 3 and time period is multiplied by 3 in the generated clock. So when we give this to a circuit, we are expecting this waveform as the output. So if master clock time period is 1 nanosecond, so generated clock will be 3 nanoseconds. So it's 1 nanoseconds, it's 3 nanoseconds. So how to design this circuit? So before going to the design of clock divided by 3, I want you to know these two topics perfectly well and understand this. Be patient, you need to understand these two topics to understand the clock divided by 3. So D flop, you need to understand the functionality of D flop in toggling mode and how the waveform works. So I'm going to explain it and mod and counter. So I'm going to explain about the D flop. So as you can see, this is a D flip-flop which has inputs of D and the clock CLK, outputs as Q and Q bar. So let us consider a clock of this waveform with 1 nanosecond as time period and D as this input. So here I'm considering setup time and hold time. This is practical waveforms. I'm not drawing the ideal waveforms. Setup time and hold time are being included. If you don't know what setup time and hold time, please check my setup time and hold time video. So this is the input which we are gonna give to the D flop. So as you can see this, we are now checking at the posage of the clock. So at this posage the value of D is 0, at this posage it's 1, at this posage it's 0, at this posage it's 1. So it's 0 from this posage to this posage, so output will be 0 from this posage to this posage. And we have some hold time, and then we'll check at this posage it's 1, so will be 1 from this posage to this posage, and at this posage it's 0, so it will continue as 0 from after the hold time from this posage to this posage and continue. One thing I want you to observe, that the input is being delayed by time period T. As you can see, it's been delayed. D is here and output is here. As you can see over here, this point arrives at this posage, so the difference is time period of T, and this point appears over here, this point appears over here. So total input is shifted by a time period of T. So this is the delay we are getting when we are checking at the posage. Understand this. This is the good concept which we are going to use it in the clock divided by 3. So we have seen the output at the posage, positive posage, and now let us check the output at the negative edge. So this is the negative edges which are not indicated with arrows, please understand. Okay, so when we are going with the negative edge, as we give the same input to the flop, and we'll check the output at the negative edge. So as you can see, at the negative edge it's 1 over here, so we are going to get 1 after the hold time, and the 1 will be staying for till next negative edge. So it is staying till next negative edge, and at this negative edge it's 0, it will be turning to 0 after the hold time, and till the next negative edge it will be 0, and at this negative edge it's 1, so it will be turning to 1 over this negative edge till next negative edge, and it will go on. As you can see here, by now you should have understood what's the difference between the positive edge and the negative edge. I hope you understood. The difference is that this delay is just t by 2. When we are considering negative edge, the difference is delay between the input and output is t by 2. It has reduced by t by 2. And where in the positive edge, the delay is t. Okay, so I hope you understood about the functionality of the D flip-flop and how the waveforms come with the delay of t and the positive edge and with the delay of t by 2 in the negative edge. Please remember this because it's gonna be super helpful in clock divided by 3 circuitry design. So now we have one more thing to learn: toggling and mod and counter. So how the D flip-flop will be toggling and mod and counter. Now let us have a look at mod and counter. So mod and counter is an asynchronous counter. Okay, it is an asynchronous counter. So let us take an number 3. N is equals to 3. So when n equals to 3, it will count from 0 to 1 to 2 and back to 0. So this is how a mod counter looks like. Mod 3 counter looks like. So mod 5 counter will be 0, 1, 2, 3, 4 and again back to 0. Okay, so how to design how many flops are there in a mod counter? So we need to design this mod and counter. So how are we going to decide? So first we need to know how many flops will be required to design a mod and counter. So we have two ways to get how many flops are there. One is logical form and one is using a formula. So I will tell you to go with the logical because it's so simple. You need not remember the formula one. No need for the formula to remember. So as you can see, let us consider a mod 3. So it will be 0, 1 and 2. The last bit, the highest bit 2 can be represented in how many bits? How many bits? Minimum number of bits. 2 bits. So 2 flops are required for each bit. So for 1 flop is required for 1 bit. Okay, so that will be 2 flops. How many flops? 2 flops for mod 3 counter. So now let us look for mod 5 counter. So mod 5, how many flops are required? So use the same method. Use the same method as mod 3. Come on, say the answer in the comments. Fast. Okay, it's 0 to 4 and back to 0. So 4, how many minimum bits are required to represent it? 3 bits, 1, 0, 0. So 3 bits means each bit requires 1 flop. That means 3 flops are required to design mod 5 counter. And similarly, one more example, I want you to answer it. Mod 9 counter, 0 to 8. How many? Respond. 0 to 8 and back to 0. This is the mod 9 counter. So 8 is represented with minimum of 4 bits. 1, 0, 0, 0, 0. So 4 bits means 4 flops. So this is the logical method. I want you to do it in a logical method rather than using in the formula method. And the formula is 2 power n greater than the counter number capital N and small n is the number of flops. So mod 3 is a capital N. So 2 power n. What is the minimum value of n where 2 power n is greater than 3? So n equals to 2. So number of flops is 2. So similarly for this mod 5. So 2 power n greater than 5. What is the minimum value of n? N equals to 3. Okay. So 3 flops are required for mod 5. So this is a small approach where we need to know how many flops are required. So we have known how many flops are required. Now let's go to design. How do we do mod 3 counter for this case where clock is divided by 3? So we are going with the mod 3 counter right now. So as you can see, I have represented 0, 1, 2 and 0 in a binary form, 0, 0, 0, 1 and 1, 0. What you can observe over here is that LSB bit is toggling 0 to 1 and 1 to 0. So LSB is toggling. So what is the important thing? So we need the flops in a toggle mode. What is meant by toggle mode? Toggle mode is nothing that our inputs are being toggled from 1 to 0 to 0 to 1. So our flop should be such that it should be in a toggling mode. So when will be a D flop will be in a toggling mode. Understand this. When will be a D flop will be in a toggling mode. So D flop will be in a toggling mode when we give the Q bar in output to D. So as you can see, D is getting the input from Q bar. So it will be in a toggling mode. So first let us say that Q is in 1 and Q bar is 0. So Q bar is 0, D is 0. Then Q will be 0. Then Q bar will be 1. Then Q bar will be sent to D. So it will be in a toggling mode just like this, 1 to 0, 0 to 1 and 1 to 0. So LSB bit is toggling. And one more thing you can observe from this is that I think you need to observe this, as when it is toggling from 1 to 0, when it is toggling from 1 to 0, MSB bit is also toggling. As you can see, MSB bit is toggling based upon LSB bit. So whenever LSB bit is changing from 1 to 0, MSB bit is also toggling. As you can see there, it is toggling from 0 to 1. Okay, this point is crucial. So MSB bit is also toggling. So we have two flops. Both flops should be toggling. So but how should this LSB bit is controlling MSB bit? So whenever there is a neg edge, 1 to 0 means neg edge. You know, 1 to 0. 1 to 0 means neg edge. So 1 to 0 means neg edge. So neg edge means we have to give the clock as negative edge. So as I said, this is an asynchronous design. So we are giving the output of Q to the clock as a negative edge for MSB bit. So now it will toggle whenever this LSB bit goes from 1 to 0, the MSB bit will go from 0 to 1. That means it will toggle, not 0 to 1, it will toggle. Okay, so this is the mod 3 counter, but it's not yet done. As you can see, it will go from 0 to 0, 0 to 1 and 1 to 0, and it will go to 3. But we don't require 3, we need 0 0. So how will we reset this value to 0 0? So whenever we'll get the output value 1 1, we need to clear the flops by using this small circuitry. So whenever it's 1 and 1, we will get the output value 1 and it will be clear. If it's not 1 and 1, will not be clear. So whenever we'll get a value of 3, we need to clear back to 0. So we need the 0, 1, 2 and 0. So we will not require 3. So we need to go back to 0. So by using this small circuitry, we can design to 0. So we can go for any circuitry like this. We can implement mod 5 counter, mod 6 counter, mod 7 counter, how many circuits you want. You can using the small principle of toggling. Understand this one. I hope you understood it, because it's so important for clock divided by 3 or clock divided by n. So I want you to do mod 5 counter and comment me if you got any doubts in there, because I will be taking another video on mod 5 counter, because mod 5 will be so simple. Mod 5 counter will have 3 flops similar to it, 3 flops which will be toggling, and this will be I don't know about this one, but there will be have 3 flops and connected in a certain fashion where it will be toggling used upon the previous output generated. So but here it will be a change. So as you can see, in the mod 5 counter we'll get output as 101 instead of 11. So we need to make, whenever 101 comes, we need to get the 1 and clear the output, because it's from 0 to 4, 0, 1, 2, 3 and 4. So whenever 5 comes, we need to clear it back to 0. So this is the only change we'll be getting in the mod 5 counter, apart from the number of flops. Okay, so I hope you understood clearly about mod 3 counter, and I hope you will design mod 5 counter and any other counters based on this explanation. It's simple. Go with the MSB, check the toggling, use the clock's output of the previous input as the clock for the next bit, and take the output from here, and check the whenever 1 1 is coming, go back to 0, or 1 0 1 is coming, go back to 0. Okay, now let us look at. So now you have been waiting for this f by 3. So f by 3, as I said, the master clock time period is by 3 divided by 3, and generated clock is 3t. Okay, so frequency is divided by 3 and time period is multiplied by 3. So how are we gonna decide this? As you can see, we have half period for 3 by 2, it's 1, half period again it's 0, 1 and 0. So we need to get 3t by 2 on, 3t by 2 off. So how are we gonna do this? I have a small circuitry which will let you do this. So we have mod n counter, and the output of the mod n counter is given to D flip-flop, and we OR this and get the output as generated. So I'm going to explain it, be patient. So it is f by n. So f by n means our case it is f by 3. So n equals to 3, mod 3 counter. As I said, we have already designed mod 3 counter, and I have explained about it, about the mod 3 counter. Okay, this is the mod 3 counter which will be in this first stage. Okay, so mod 3 counter, it will have this outputs 0 0 1 and 0 1 0. So it will be toggling like this. So we have two chances over here. We can either take the output as Q0 or we can take the output as Q1. So for a better understanding, let us take the output of mod n counter as Q1 0 0 1. So this Q1 is passed to D flip-flop. So what will happen when we pass to a D flip-flop and it is negative edge? Understand this, it's a negative edge. So I have said about it in the starting of this video. Whenever we pass through a flop and it's a negative edge, the delay of the input will be t by 2. The delay of the input and the output will be t by 2. So now I hope you understood why I said D flip-flop is so important. So the delay is t by 2 and we are ORing the output. So to get a clear understanding, let us have a look at the waveforms. Okay, as you can see over here, so this is the clock, and we want from this clock, we want this clock 3t by 2, 3t by 2. Now this clock is giving us the output as 3t by 2 using this circuitry. So let us look at it. As you can see, the first stage output will be taken from Q1. It is 0 0 1. So it is the 0 0 1 and 0 0 1, so on it continues. So this is the Q1 output. You can go for Q2, but Q1 is advantageous. I will say later why it's better than Q0. Okay, 0 0 1 and 0 0 1, it's continuing, and we are giving this Q0 to D flop. So we are giving Q1 to D flop. So what we'll get is a delay of t by 2. So 0 0 0, and there is a delay of t by 2. Okay, now we are ORing it. Now we are using an OR gate to get the output. As you can see, it will be 0 0, it's 0 0 0, it's 0 1 0, it's 1 1 1, it's 1 0 1, it's 1. So we have a time period of 1 and we have an extra t by 2 added. So we are getting 3t by 2 on and 3t by 2 off. Okay, I hope you understood. 3t by 2 on and 3t by 2 off. So this is the output of it. So this is how we design frequency divided by 3. So if we take 5 as an mod 5 counter and give it to this, but we need to check which bit we need to give, either Q1 or Q0 or Q2 for mod 5 counter. Here I took Q1 because it's easier than Q0. If you have taken Q0, we need to toggle every bit and we need to OR it. It is easy, but we can do it. So I will be designing F by 5 in another video. If you understood this topic, you would be doing F by 5 easily. So I hope you understood. If you like this video, please subscribe and do share this video, because I did this on papers. I don't have any markers, so it takes time for paper work. Please do subscribe for paperwork and the concept you learned. I hope you like this video. If you like this video, give a thumbs up and subscribe. I'm shouting to subscribe because I need some support from you guys who are watching. Thanks for watching.